Hey everyone, welcome to this session. Thank you very much for having me. It's great to be here. So, my name is Laszlo. My name is Lazlo Bence Nagy. I am a software engineer at Cisco, and I previously worked at a startup called Banzai Cloud, which was acquired by Cisco. At Banzai Cloud, we started to work with Istio a while back. It was like the end of 2018, I think. It was prior to Istio 1.0 release, I believe. So we worked with Istio for quite some time now, and we were particularly interested from the start in the Istio multi-cluster capabilities. So we worked with that a lot, and my talk today is about that one as well. The title is Multi-Cluster Istio Mesh. Is it complex or a piece of cake? And I'm letting you know right now that I will ask the same at the end of my presentation as well. And you might have some idea about this right now, but I hope that my presentation will alter your thinking a little bit about this, at least a little. So let's see our agenda. Actually, I prepared quite a long session for today, so good luck for staying until the end. The agenda is fairly easy, actually. I'm planning to do a lot of demos today. So I'd like to introduce you to two open source tools that we have developed. So today, I'm not going to talk a lot about the actual state of the multi-cluster setups in Istio today. Rather, I will talk about what we did to improve it, to automate it for ourselves. But these are open source tools, so for everyone that might use it. So I will introduce these two open source tools, then I will briefly talk about the current Istio multiprimary setup, and I will show it in action how to do that with our two open source tools. Then I will touch upon the primary remote setup and show it in action as well with our tools. So let's see the first one, the first open source tool. It's called Cisco HT Operator. And if you will be just a little bit more enthusiastic about this tool than this girl right here, then I will be very happy. So the Cisco HT Operator, first I have to say that this is not the official or community Istio operator that you might be familiar with. This is a completely different implementation, not a fork or anything like that. They are very much different. We actually started to implement this operator before like the Istio 1.0 release. Like in early 2019, it was open sourced already. And at that time, they haven't even started to work on the official Istio operator, actually. So this one existed before the official one. And you might remember this by the name Banzai Cloud Istio Operator. Now, since the acquisition, we usually refer to it as Cisco Istio Operator. Of course, it does similar things as the official Istio operator. So it, of course, manages upstream Istio. You can install Istio with it, configure, upgrade, all the usual stuff, as you would imagine. But what are the differences, you ask? Let me just highlight two things. One of the things is that we have seen over the years that it was quite cumbersome or not very straightforward to create and configure multiple gateways with upstream Istio. So for that, a while ago, we introduced a support by introducing a separate custom resource. We call it Istio Mesh Gateway. And with that custom resource, you can very easily create any kind of ingress and egress gateways in any namespace with the right ownership, with the right permissions. So that's one thing. And the other thing, and the bigger thing probably, is the multi-cluster support that I'm going to talk about today. Let me also say that sometimes operators, generally Kubernetes operators, got the critique that they are just installers, basically. I think this whole multi-cluster support that I'm going to be talking about today is a prime example of the operator pattern can be used for much, much more than just being an installer. And also, lastly, about this operator, in case you are wondering, it's still actively maintained. So even though it's there for a long time now, almost 4 years, they are still actively working on it. For example, this whole multi-cluster support was rewritten from scratch last year, actually. And for example, as you will see, I will demo already with Istio 1.15, which is not even released yet today. So yeah, we are working on this actively. Next tool is called Cisco Cluster Registry. I hope you are as hyped as this guy to hear about this. So Cisco Cluster Registry is a fully separate open source tool, open source project. It in itself, it has nothing to do with Istio or service meshes. It is a fully generic tool for multi-cluster Kubernetes use cases. Of course, we use it with Istio Operator for this specific multi-cluster use case that I'm talking about today. But other than that, this aims to be a fully generic tool, because what it does is that it can synchronize Kubernetes resources between multiple clusters. And we think that that can be used for a lot of other use cases as well, not just for this Istio one. By the way, if you are interested more in this tool, we will have a session dedicated to this, the Open Source Summit EU. So check it out if you are interested. I will just say one thing about this, which is particularly interesting. I think that this tool is fully distributed. There is no central component, no single point of failure in the system. And yes, as I mentioned, with the Istio Operator, these two tools enable all kinds of nice enhancements for the Istio multi-cluster setups. So I hope that after you see my presentation, you will think that these two open source tools are meant to each other, like these people on this tweet. On a more serious note, let's take a look at the multiprimary and different networks setup first. So this is the official Istio multiprimary and different network setup. In this setup, we have one single Istio mesh. Those are federated across multiple Kubernetes clusters. And the primary means that there is an Istio control plane, actually practically an Istio-D running on both of these clusters. And the different network means that there is no pod-to-pod connectivity configured between these two clusters, which means that pods from cluster 1 cannot directly reach pods running on cluster 2. Rather, they will need to communicate over a dedicated ingress gateway. To set this setup or topology up, according to the Upstream Studio documentation, you need to do several steps, which are here in bullet points real quickly, is that you need to configure the trust relationship between these two clusters. You need to set the networks so that they are communicating over the east-west gateways or not. You need to install the east-west gateways. You need to create and configure the Istio configurations, expose the services between the clusters so that they can be reached from one another. And also you need to enable endpoint discovery because Istio-Ds needs to know about the available endpoints from the other cluster as well. This might not look that scary, actually, if you just take a look at this list, but I do want to scare you a little bit, honestly. If you take a look at the Istio documentation, this is the multiprimary and different network setup that I'm just talking about. So first, there is this before you begin section, from which the important part is that you need to configure trust. And there is a whole doc about how to do that with a common root trust-based approach. Then after you do that, you need to run all these commands to set this up. So some kubectl commands, applying some Istio operator CR, running some scripts, Istio-ctl commands, applying some YAMLs. Then you need to do the same thing for the other cluster as well. Then you need to run some Istio-ctl commands and apply some resources from one cluster to the another. And then, congratulations, you are ready. But what we found is that this is not very convenient. So we wanted to automate this and make this better. And that's what we did. So let me show you with these two open source tools that I mentioned how this works. I have two Kubernetes clusters right here. The first one is called primary 1, the second is called primary 2. These are running on AWS, by the way. So what I have installed on these clusters, sorry, let me move this. I can. I'm trying to move this Zoom tab because it's kind of in my way when I'm typing, but I'm not sure if I can do that very efficiently. Anyway, that's the best I could do. All right, so what I have installed on these clusters is the Istio operator and the cluster registry controller, these two open source tools that I've been talking about. And I did one more thing as a preparation, which is I made sure that the resources can be synchronized between these two clusters with the cluster registry. To do that, that was an additional manual step. Actually, it's pretty easy to do, but I deliberately don't want to go there and talk about cluster registry. I'd like to focus on the Istio-related stuff today. I just wanted to mention that and admit that there was this additional step that I needed to do. But other than that, we are starting from scratch. So we have no Istio-Ds running, no Istio control planes, configuration, CRDs whatsoever, nothing on these clusters. And what I'm going to do is that I'm going to apply 2 CRs to these clusters, which I just did. And let me show you the content of these CRs. So these are Istio control plane custom resources, which is a custom resource for our Cisco HT Operator, based on which the Istio Operator creates the Istio control plane, meaning the Istio-D and any other resources that might be needed based on the configurations provided. And these two CRs are almost identical. There is just one difference between them, which I will highlight, but it's enough for now if we take a look at the first as I'm explaining. And also, I just have to say that in the Istio docs, as you could see, this very similar CR was called Istio Operator, which is honestly very weird to me. So basically, based on this resource that is created an Istio control plane, not an Istio operator. So even if you are not installing Istio officially with Istio, with the official Istio operator, you need to create this resource, and it's not even what you are creating. You are creating the Istio control plane. So it's just very weird, that naming to me, and that's exactly why we didn't use that. We went with this Istio control plane name instead. Sorry about that. So let's get back here. But of course, it has a name and a namespace, this resource. And then it has a version. As I mentioned, it's using already the latest Istio 1.15 beta release that's out there. And it's using an active mode, which is essentially the same as the primary in the multi-primary term. It's just been keep changing these terms in the Istio terminology over the years and over the releases. It was not always primary, and primary remote. They were called differently. And we just did not follow that. We just went with the active passive terminology instead. As you will see, there will be kind of few of these differences as well. For example, another difference is that we are not, so this mesh expansion is basically the east-west gateway in Istio's terminology. We just opted to go with the mesh expansion name. But basically this tells that to install this east-west gateway. And there are some other settings which are needed for the trust relationship. I will talk about that later today. So yeah, and what's the difference between these two CRs is that the network is set differently, network 1 and network 2 between these two. And that is because this is the different network setup. There is no pod-to-pod connectivity configured between these two clusters. They will instead communicate over the east-west or mesh expansion gateways and talking to each other. All right. So this is what I did. I applied 2 CRs to these two clusters. That's all I did. And if you remember this doc, you need to do several manual steps to make this work. But the thing is, all those manual steps were done automatically in the background by these two open source tools. Let me prove that to you. So, first of all, the easy part is that, of course, there is an Istio-D and Istio control plane running on both of these clusters. Then there is the Istio mesh expansion gateways, the East-West gateways running on both of these clusters as well. Of course, they have some external IPs so that they can be reached from each other. This is the easier part. Another thing we need to do to make this setup work, the multi-primary setup, is that we need to enable endpoint discovery between the two clusters. So an Istio running on this cluster needs to access not only this Kube API server for endpoint discovery, but the others as well. Because since we are on the same mesh, just on multiple clusters, there can be other pods running here, which needs to be accessed from the other cluster, and that needs to be discovered by Istio, by both Istio's, so that they can have the same envoy configurations. So how do we do that? Let me take a look at the secrets on these clusters, and as you can see, there is this secret right here, which is basically the cluster name and the Istio control plane resources name together. So if you take a look at this resource, you will see that there is some base 64 encoded something right here in this secret. So let me just decode that for us. And what we will see is that this is actually kubeconfig. This is a kubeconfig for this first cluster right here. And what happens is that there is an Istio operator running on this cluster, and when an Istio control plane is created, based on that, and based on the Kube API server access, it generates a kubeconfig like this for this Kubernetes cluster itself. And this Kubernetes cluster, by the way, has a Istio reader user, so it will have very limited reader capabilities to be able to do the Istio service discovery. But this resource is on this cluster. And for this Istio day to be able to reach this Kube API server, this secret should be on this cluster. So what we would need, essentially, is that we should synchronize this Kubernetes secret from this cluster to the other. And if you remember what I said about cluster registry, I said that it can synchronize Kubernetes resources between clusters. So we are going to use exactly that. And there is a custom resource called resource sync rule. There is this multi-cluster secret plus resource sync rule specifically that I'm going to show you today. So this resource sync rule is a special custom resource for the cluster registry controller with which you can define which kind of resources and how to synchronize between the clusters. This has a very extensive API, by the way, but I will only focus on today on what we need for this Istio multi setup. So from all this, the interesting part is that this resource sync rule tells the cluster registry controller to synchronize secrets between the clusters. It actually synchronizes this secret with this type. So if I check this secret that I just showed you, it has this Istio reader secret type, which is right here. So it synchronizes those kind of secrets. And it synchronizes secrets with this label. This is basically just to make sure that we only synchronize the right Istio control plane version secrets. And there is an additional thing here, which is a mutation, which basically tells the cluster registry controller to not only sync secrets from one cluster to this one, but looks like our meeting will end in 10 minutes. Not sure what to do there, but if you don't interrupt me, I will go on for now.
Yeah, please keep going.
Okay, should I be real quick and wrap up in 10 minutes, or should we do something else?
I just clicked on, I think it should be fine now. But yeah, please, can you please try to just like upload it?
Do what? Sorry, I didn't catch it.
What did it say for you?
So it says for me it is counting the time left for me, like 9 minutes left right now. And it also said that we should upgrade the free Zoom account. So I don't think that's possible right now.
We do have, there's something with the configuration of Zoom today. Let's just keep going with this one. And If not, we can restart this session just to finish it. Okay.
Okay. Oh, all right. Let's do that. We'll see how that goes. All right. So as I was saying, we are adding this mutation, this label to this secret as well. That is needed for Istio. I will show that in a sec. So if I check this secret right here in this cluster, I will see, not even that first, sorry. So let's see the secrets on this cluster. As you can see, the same secret is already on this cluster as well. So, and this is synchronized here by the cluster registry controller because of this resourcing rule that I just explained. So if we check this secret, it would be the same as we saw. And on this cluster, as you can see, it only has this Istio IOREV label. On the other cluster, it has the same label, but it also has this Istio multi-cluster label, which was defined by the resourcing rule. And also it has another label called resource owner cluster ID, which, by the way, tells us that this was actually synchronized by the cluster registry controller, and it just shows a unique ID, which is a unique ID for this first cluster, by the way. So this secret is right here, and IstioD needs to pick it up. So how IstioD will do that is that if we check the IstioD logs, we can see that from this secret, it picked this cluster up, and based on that, it's able to do service discovery. All right, this was about the service discovery part. Next up is trust. That could be a very long session to talking about trust, but I will try to be brief here. So by default, the community recommends the common trust based approach. Well, we don't use that. Common root trust-based approach means that the root CA is the same for both of these clusters. Rather, we use so-called federated trust-based approach. So the root CAs will need not to be the same between these two clusters. The idea is, I will show that in a sec, the idea is that instead, we will show the root cert of this cluster to this other cluster and the other way around, and basically let them know that please allow certificates signed by this root CA to talk to this cluster so that mutual TLS traffic can work. I will show how this works. Why we went with this federated trust-based approach? Well, for once, with this, it can be automated. It's much easier to set up because, as you saw, as I showed in the before you begin section, even before you start setting up your Istio control plane, you need to configure these certificates for both of your clusters, or no matter how many you have. And with this solution, I didn't do anything like that. They can have totally separated root CAs and still able to communicate to each other. It can also be very helpful, for example, when you need to do some certificate rotations, for example. So that's why we use this federated trust-based approach and how this works. So let me show you the root CAs in both of these clusters. As you can see, based on the end of these certificates, these are different on both of these clusters, and still, if you believe me, the communication, MTLS communication would work between pods in these clusters. But how? So what we do is that there is a resource, there is another config map, Istio config map on the clusters, and in which there is in the mesh config there is this field CA certificates. This is an upstream Istio feature. This is not coming from us. So in the CS certificates mesh config field, you can specify other certificates that will be trusted by this cluster for communication. And as you can see, this one right here is the same as this one. So basically, we do this, that we make sure that this comes here somehow, and with that, it should be possible for the MTLS communication to work. But the big question is, how did this from this cluster get here? As you might imagine, we will need some cluster registry magic again to come here from here. And what we do basically is that, let's take a look at this Istio control plane resource that we created. Earlier we saw the spec of this resource, which I created, but in the status, the Istio operator writes this certificate from this cluster, and we synchronize this resource to the other one. But that synchronization is pretty unique, I would say, because it synchronizes this Istio control plane resource by its namespace name, but there is a very interesting mutation that we use, which is my favorite actually, is that we change the kind of the resource. So on this cluster, this is an Istio control plane resource. But on this other cluster, this will be actually be an Istio control plane resource right here. So it has the same spec, the same status, but the kind of it is different. And as you can see, the name of it is different as well, because we are appending the cluster name to the end, like this. This is just to avoid collisions. You know, if from other clusters, the same resource with the same name would be imported, and then they won't collide. So basically, this same resource is here. And of course, if we take a look at this one, then we will see in its status the same root set that we need. And from here, the local Istio operator on this cluster sees this resource, and based on that, it will set it to that mesh config field, CS certificates field that I just showed you. That's how the federated trust solution works for us. So, as I was saying, the last thing I wanted to show regarding this multiprimary setup is that, so we set everything up for this multiprimary setup. I kind of showed most of the interesting stuff, how we did that. But after you set this multiprimary setup up, then it's usually nice to have the Istio configurations, the Istio CRs, destination rules, virtual services, etc., synchronized across these multiprimary clusters to have the same Istio configurations for both Istio-Ds. And to do that, you can either do that manually, you can either use some external tools like either GitOps tools, or there are some other tools that can be used for something like this, not necessarily for the Istio CRs, maybe for the services themselves. So for example, Admiral is a tool like this, and the other one is the Multi-Cluster Kubernetes Services API, aiming for something like this. But the point is, these are all external tools, and out of the box in Istio, these are not supported. With our open source tools, Istio Operator and Cluster Registry, it comes for free as well. So let's take a look at the peer authentication resources, for example, on these clusters. There is none on these clusters. So let me apply this strict peer authentication rule to this first cluster. I just created it, it's already there. And if you check, it's already created on the second cluster as well. And if we take a look at the resource in detail, you will see that this is a single peer authentication, and the other one, there is an additional label, the cluster ID label, which shows us that this was actually synchronized here by the cluster registry controller. There is actually a resource sync rule for this one as well. We can take a look at that. It actually synchronizes the resource based on the labels that's on it. So it either synchronizes the CRs if it matches the Istio control plane version, or if there is no label regarding the Istio revision on that particular custom resource. And this is for peer authentication, but of course for any other Istio config custom resources, we can do the same. So again, this is an additional stuff after you set up the multiprimary topology in Istio, and you can either use these external tools for it, or with our open source tools, this comes for free as well. So that's all I wanted to show about the multi-primary setup. And I'd like to talk about the primary remote one as well. That will be much shorter, hopefully. No, it will be much shorter for sure. So the primary remote on different networks setup has a lot of similarities to the multi-primary one. The difference is that there is no Istio control plane on the remote cluster, on the remote side, which is basically essentially an Istio D is not here on this cluster. This comes with additional stuff we need to do, because from the second cluster, from the remote cluster, the proxies, the Istio proxies running inside the pods will need to get Istio Envoy configurations. And because there is no Istio D on those remote clusters, they will need to reach the Istio D on the primary cluster to be able to get those Envoy configurations. And to do that, there are some additional stuff we need to do. For example, exposing the Istio D basically on the primary cluster so that it is accessible. And we need to configure basically an access to that Istio D from the remote side. And of course, I could do the same thing as I did with the other one. With the multi-primary setup, I could show this, that there are a lot of manual steps, and what we did instead is that we automated this setup. So let me show that. So let me grab another cluster, which is called Istio Meetup Remote 1. Let me also set this M1. And after that, what I'm going to do is that we have a multi-primary setup right now, and I will attach a remote cluster to this. So we will have a primary remote setup right away. To do that, all I will do is just apply this YAML again. Let me show you what's in there exactly. It's a little shorter than the previous ones. As you can see, that's all I applied, and the setup should be ready automatically in the background as well. So it's yet another Istio control plane resource with the same namespace name, with the same Istio version. The difference is that this is not an active, rather a passive or remote in Istio's terminology control plane. And it is yet another network free, because still no pod-to-pod connectivity configured, so they will communicate over the east-west or mesh expansion gateways, which are enabled, and we are enabling another mesh config setting as well. So that's what I did. And if I take a look at the pods, you will see that there is a sidecar injector running on this cluster, which I need to explain. Because so at least last time I checked the current community Istio setup for this primary remote one, they actually install an Istio D on the primary side. We just talked about that the remote means that there is no Istio control plane running on the remote side, but it is not an actually full-fledged Istio D that they were installing. It was a very limited and simplified Istio D, doing only two things which are important as far as I'm aware. And those two things were, one is the sidecar injection. So pods running in this cluster, when they are created, the Istio proxy sidecars are injected to them. And the other one is creating the root CA config map to be able to have the trust between these two clusters. So it's a simplified Istio D doing these two things. We do this differently. We only install an Istio sidecar injector pod. And by the way, there is no sidecar injector Docker image available anymore since the Istio D merge. So basically we fork this and maintain this fork for ourselves for the sidecar injector. So what happens is that we install the sidecar injector, and this is of course responsible for injecting the sidecars to the proxies. And about the trust, we solve it differently. I will show that. Yeah, so we have the sidecar injector, and we have, of course, the east-west mesh expansion gateway installed as well. The next thing I mentioned is that the proxies running on this cluster, we need to reach the other Istio Ds to get the Istio configurations, the Envoy configurations from them. Now, let's see how that works. let me take a look at the services, and that is this Istio service. This Istio service is here so that Kubernetes can do the DNS resolving for this name. And as you can see, this is a headless service with non-cluster IP. That is because there is no Istio running on this cluster, right? So instead of letting Kubernetes create a cluster IP service like this with a pod in this cluster, because there is no pod, it actually creates the underlying endpoints, Kubernetes endpoints for this resource. These endpoints have these addresses set. And what are these addresses? If we check the east-west gateways, or as we call them, mesh expansion gateways on the other two clusters, we will see that these 4 IP addresses are the same, or should be the same as these 4 right here. And this is because, let's see, a service needs to access an envoy config. It calls the svc cluster local hostname. Kubernetes resolve this, and it will see these endpoints under it, and it will call these addresses. It will direct to this cluster, for example, or the other one. And of course, on the other side, there is some Istio magic with gateway and virtual service, which are making sure that if traffic pointing to Istio are coming here, these will be directed to the Istio pods running on this cluster. So that's the idea. And that's pretty great, but how these IP addresses got here? Well, we got that nice Istio control plane resource that we talked about already today, which contained in its status these certificates. Well, the certificates are not the only thing that are stored here in the status. There are other stuff as well. For example, the gateway addresses. So for this primary one cluster, for example, you can see these 2 addresses are the same. So what happens is Istio operator running on this first cluster, it locally reconciles to the Istio control plane resources status, to this resources status, these addresses. Then with the resourcing rule, cluster registry controller copies this resource here. Here are the gateway addresses. And based on that, Istio operator running locally on this cluster, based on these addresses, he feels that Kubernetes endpoints resource to have these addresses, and of course the other ones as well for the other cluster right here. That's how this works for us. And another note about this, that so far I've been only talking about the different network setup, but as you might know, there is a flat network or same network setup as well, which means that if there is pod-to-pod connectivity configured between the clusters, but in that case, you can actually call the Istio directly with its pod IP address. So if I check, for example, this Istio has this address right here. And as you can see, by chance, we have this same address in this resource status as well. So if Istio operator sees that the network is the same between these 2 clusters, the network is set in the Istio control plane resource, so it is aware of that. If it sees that the network is the same, then in the endpoint, Kubernetes endpoint resource, it will not set these gateway addresses. It will instead set the Istio address. And that way we can also support the flat network setup as well for Istio. All right. Speaking of these addresses, let me show you one more time this Istio config map, because in this there is another stuff that is interesting, which is this mesh networks setting right here. This is basically, to let Istio know what are the networks here and where to route, in which case, basically. And basically, this is a network list containing the registry and the IP addresses where those networks are accessible. And this list is basically formed based on these Istio control plane resources as well. So in these resources, we have the networks available. We have this, this is basically the cluster name as well, accessible, and these IP addresses as we just saw as well. And this is, again, fully automatically, Istio operator knows this from this resource and figures this out for Istio. Last thing is the CA stuff. So I mentioned that instead of Istio D, we have an Istio sidecar injector. So sidecar injector is checked, but the other thing is the trust. How do we handle trust? Since there is no Istio D here, Istio D cannot create the Istio CA root cert config map on this cluster, but as you can see, it's still here somehow. If we take a look, then actually you will see that this one is the same as this one in the first cluster. As you can see, they end the same way. For the primary remote setup, we are using the common trust-based approach as well, not the federated trust one. We only use the federated trust one for the multi-primary setup. And how did this resource get here? Is that you can already tell by the label that this was actually synchronized by the cluster registry controller as well. There is a resource sync rule for this as well, called this one. And what it does is basically, as you can see, very easy, synchronizes the config maps with this name to every namespace. And that's how on the remote side, we will have trust available as well for MTLS communication between these two clusters. Last thing about this, now really the last one, is that we feel basically that the remote side should be as lightweight as possible. So ideally, not even have this sidecar injector port here, only the Istio proxies running next to the replication containers. And to do that, Istio D has, official Istio has the Istio D for the CA support and sidecar injection. We only have the sidecar injection because CA is solved with the cluster registry controller. And by the way, we also have a proof of concept solution where this sidecar injector is not even here. Rather, then the mutating webhook on this cluster is called from this cluster so that sidecar injection can happen on this side again without any pod. But that's maybe for another time. All right, I will soon finish, guys. So basically what I showed you today is that this single mesh multi-cluster Istio setup is almost fully automated by these two open source tools, HT Operator and Cluster Registry. So basically with these, you can very easily create any number of primary and any number of remote clusters to be in the same mesh. And again, let me remind you that I say almost fully automatically because there was that additional manual step which you needed to do for the cluster registry to be able to synchronize the resources between the clusters, which I did not show. But other than this, I honestly got to say that we are very happy with this solution. It works pretty well for us. It's very stable, very convenient to create multi-cluster meshes like this. And the other thing is not only setting these up, but because these are operators, these are keep running in the system and keep reconciling the clusters. So if anything changes, either by accident or it could be a malicious user as well. But if anything changes, the operators keep reconciling it. So they will keep the multi-cluster state in a stable way. So it's working pretty great for us. Another great thing about the operator pattern is that it supports very well the declarative and GitOps workflows. So you basically install the operators to your cluster, push these CRs, Istio control plane CRs, and based on that, you get pretty easily all this setup created as well for yourself. And lastly, I mentioned this Istio config synchronization. So after you set everything up, and by the way, as I mentioned, it's even the multi-primary, even the primary remote, and even the different and the flat network setups as well works for every one of these. After these, you would need the Istio config synchronization feature. With these two open source tools, you get that for free as well. So, as I warned you at first, it was a very long time ago. You might not even remember it, but I will ask the same again. That is Istio multi-cluster complex or a piece of cake? Maybe I could change your mind a little bit. And if you guys let me, I would do one marketing slide as well. So if you don't want just one piece of cake, rather you want the whole cake, then you should try Cisco's product called Callisti. which you can actually try for free, by the way. So in this tool, we basically have a CLI tool with which it is actually fully automated, all these multi-cluster setups. So with one CLI command, you can attach and detach Kubernetes clusters into an Istio mesh very, very easily and conveniently. And this product is much more. It comes with the UI. As you can see, its topology view is fine-tuned, optimized for the multi-cluster setups, and it has much, much more features. So if you are interested in that, go to caristi.app, check it out. You can try for free. If you're interested in all these open source technologies, HT Operator, Cluster Registry, you can find them on GitHub. Please create issues, PRs, or just reach out to me. There's my email address as well. That's all I wanted to share today. Thank you very much for having me, and I'm, of course, still here and very much open for questions.